So did we finally see the dark matter? It's everywhere on the news. So after nearly 100 years of searching, scientists have detected a gamma ray glows at the center of the Milky Way that look exactly like dark matter particles colliding and annihilating. This may be the first real observation hint for dark matter. So let's talk about what is dark matter and what is this halo. So dark matter is invisible substance that doesn't emit light or reflect light, but its gravitational hold galaxies together. Even galaxies is surrounded by a huge bubble of dark matter we call the halo, and the halo is dense in the center of the galaxy, which is where the dark matter collision could happen most often. So what is this telescope and what does it detect? So the data comes from this NASA Fermi Gamma-ray Space Telescope, which observes universe in the gamma rays, the highest energy from the light. This Fermi Gamma-ray Telescope can detect individual gamma rays photons and map where they come from in the sky. And gamma rays are very important because dark matter annihilation is predicted to produce them. So what this paper have found is that researchers analyzed more than decade of Fermi data around the galactic center. After subtracting all the known sources like pulsar, supernova, remnant, a round symmetric gamma ray glow was remained. So a lot of other things also produced gamma rays, and they subtracted all those known sources. And when they insert a dark matter halo model, as you can see in the left side, a signal becomes smooth and matches the expected shape from dark matter annihilation, and the gamma rays are around 20 GeV, which is consistent with several dark matter models. But so is it a fluke or is there something really happening? Well, the community is split between excitement and caution. Okay, so this signal has the right shape energy, but the galactic center is extremely messy, and astrophysical backgrounds are hard to model. And this analysis was like this data was reanalyzed. So people have analyzed this model, this data before, and they did not find anything. So more tests are needed, independent reanalysis, comparison with if this is the dark matter, you also want to look at other places like dwarf galaxies where you could find dark matter and check your assumptions. Like you should be able to find dark matter at other places. You also need to check with alternative explanation like unresolved pulsars or supernovas and all the other things. The current mood is questions. It is not confirmed, but it is strong as hint in years, but it seems like it might just be a fluke and not a real signal. So, but we need more confirmation. We need more reanalysis, and we need to check more. We don't know what is it yet. It's a single author paper that was published, so could be a fluke. So I hope you like this video. If you do, give the thumbs up, and I will see you next time. Like, share, and subscribe. Right.